Now, welcome back to our Post 1 tutorial. Yes. Now, this is our Post 1 tutorial. If today is the first time you are visiting my channel, make sure you tap on the subscribe button. Yes, then share the video to friends and then families. Yes. Now, today we are coming to talk about sequence and series, specifically patterns of numbers. Patterns of numbers. Or number pattern. Numbers usually follows a particular pattern, and that is what we are going to talk about. Now you see, we have numbers like even numbers, the numbers that we know already. We have numbers like even numbers. And you know, even numbers follows a particular pattern. Even numbers, that is 2, 4, 6, 8, 10. This one is following a particular pattern. We can also talk about odd numbers. Odd numbers. Now these odd numbers are also following a particular pattern. Yes. Now, so we are going to talk about patterns of numbers. I'm just using these two as an example. We can also talk about natural numbers that also follows a particular pattern. We can talk about the composite numbers and then all other numbers. Yes. Now, with this particular question, when we have patterns of numbers, numbers that follows a particular pattern, there are a lot of things we can talk about. Now, this one is being grouped into sequence and then series, and that is what we are going to talk about. Yes, sequence and series. Yeah. Now, when we talk about sequence, what does it mean? And then series, what does it mean? Now, when I talk about sequence, I'm talking about a set of numbers or quantities that is in a given order. A set of numbers or quantities. Sequence is a set of numbers or quantities in a given order. Now the word here is order, meaning that particular numbers are ordered. Yes, follows a particular pattern. Now another way I can define sequence is set of numbers that follows a particular pattern. Now this is another way we can define sequence. So we are talking about numbers that follows a particular pattern, and then we are going to break it down. The particular pattern we can talk about. Yes, we're going to break the particular pattern down. So follow me closely as we dive into this sequence and series. Now we have two types of sequence. Yes, we have two types of sequence. Now we can talk about plenty sequence, but let me say that the sequence of numbers can be grouped into two. Yes. Now we have one called a finite sequence. Finite sequence and an infinite sequence. Now we say when something is finite, it means the last number is known. You get it? Now when I talk about even numbers, the even numbers follows a particular pattern. You see, even numbers we have 2, 4, 6, 8, 10 in that order. Now this numbers follows a particular pattern in such a way that you can generate the first number, you can generate the second number from the first number, generate the second number, the third number from the second number. We can just look at the pattern that we follow. So with this one, looking at things, you can easily predict that the next number will be 14, the next number will be 16, because you can see it clear that it is either addition of 2 or subtraction of 2. Either you add 2 to the preceding number, or you subtract 2 to the preceding number. Yes. So it is the addition of what or subtraction of number. It depends on how you're going to take it. Yes. Now, these particular numbers can be grouped into two, either finite or infinite. And then since sequence and series is concerned, you have to be able to know the finite sequence and an infinite sequence. Now, when a number has if the last number of that particular set of numbers is known, if the last number of that particular set of numbers is known, then this one is known as the finite sequence. Now this is finite sequence because the last number is known. The last number is known. Yes, so this one is a finite sequence. Now let me talk about infinite sequence. Infinite sequence is the one to which the last number is not known. Now this one means that the number is not up to 8. The 3 dots means that there are more numbers there. And since the last number is not known, we call this one infinite sequence. Infinite sequence. The same way we have the finite series and infinite series. But what I want you to know is that whenever we talk about finite, it means the last number is known. When we talk about the infinite, it means the last number is not known. Yes. And then as we'll be seeing question in this particular form. So when you get a finite, you know the last number is known. You know how to solve it is different from how we can solve the infinite one. Now, let me explain what is called series. Now, let me explain what is called series. Now, when you say series of numbers is just like a sequence of numbers. So I can say that series of numbers is the addition or summation of sequence of numbers. Sequence of numbers. Now, you know sequence of numbers, right? So example 2, 4, 6, 8, 10. Now this one is infinite sequence of numbers. Now this one is sequence. Now let me change this one to series. What is series? Series is saying that addition or summation. So when we add the sequence of numbers, we get a series of numbers. Yes. So the series of this particular form will be 2 plus 4 plus 6 plus 8 plus 10 plus ... And this is how we can talk about the series of numbers. So the moment we add the sequence of numbers, we have series of what? Numbers. Now, since this one is talking about addition or summation, we have a symbol for addition. Addition symbol is sigma. Don't forget. Sigma is the symbol for addition or summation. Now at this point, I want to talk about the series of numbers in a short moment. Then in our next video, I will talk about sequence of numbers, because sequence of numbers is very broad. Yes. Now I am limited. I want to limit this one to only the SHS syllabus, New Curriculum syllabus. Yes, for West Africa. Now, so let me talk about the series of numbers. Series. Now I want to tackle the series. So series is the summation of what? Sequence of numbers. That is summation of numbers of a particular pattern. Yes. Now look at something. I can have odd numbers. Now these are odd numbers. Now we can have a general formula for this particular odd numbers. I can say that this one is the same as summation of adding the whole of these odd numbers. What will be the end term of an odd number? Odd number will be in the form 2x minus 1. When I have anything like this, that one they are all odd numbers. So I'm adding the numbers from 2x minus 1. I'm adding 2x minus 1. Now, so what we are using here is the symbol sigma. Now the sigma, we write something here, and then we can also write something here. Now this one means that we are adding the numbers starting from this particular number here down here. So starting from, let's say, x is equal to 1 up to, let's say, s is equal to 5. S equals to 1 up to x is equal to 5. And then that is the summation talking about. So I am summing 2x minus 1. I am adding 2x minus 1 from s is equal to 1 up to s is equal to 5. S equals 1, s equals 1 up to s equals 5. And that is what we're going to talk about. Now, so when we see a question like this, how are we going to do it? This one is an odd number, so I'm going to get something like this, yes. And this one is a series of numbers. This is how we can just simplify a series of numbers. So let's see. So sum of x is equal to 1 up to s is equal to 5 of 2x minus 1. How are we going to solve this one? Let's start. Now this one means that wherever we see x, we put 1 there up to the fifth number. So x is a whole number, x is always a whole number, yes. Now so we're going to have the first one being 2x is 1 minus 1. This will be our first number. Now the second number is when s is equal to 2. So we are going to input the value of x, which is equal to 1, is equal to 2, 3, up to the last number, s is equal to 5, then we are done. Yes. Now the next one is s is equal to 2. So we have 2x is 2 minus 1 plus the next one, s is equal to 3. So we're going to have 2, the x here is 3. Where you see s, you put that particular value there. Now s is 3 minus 1. Now the next one is we are moving to the value of x when s is equal to 4. So s equals to 4, come and put the 4 here. We're going to get 2x is 4 minus 1. The last one is when x is 5. That is 2x is 5 minus 1. Now at this point, you have to just try to deal with it. Now this is 2 times 1, 2 minus 1 is 1. Now this one, 2 times 2 is 4, 4 minus 1 is 3. This one is 2 times 3 is 6, 6 minus 1 is 5. This one is 2 times 4, 8 minus 1, 7. And this one is 2 times 5, 10 minus 1 is 9. Now, do you remember that I said this one is the summation of what? Odd numbers. So we have 1, 3, 5, 7, 9. They are all odd numbers. So this one is the general formula for an odd number. Yes, a general formula for an odd number. So this one shows that we are summing this particular odd numbers from s is equal to 1 to s equals to 5. So it's very simple like that. So let's see, now 1 plus this one will give us what? Now we have 10 plus 10, so everything will give us 15. It means the answer, so adding odd numbers from 1 to 5 will give us what? It will give us 16. It will give us 15. Now let's take another question. We are on a series of numbers. Now we are taking another question. Now I am adding. Now at this point I want to talk about even numbers. What's the general formula for even numbers? General formula for even numbers is 2n. Now I'm using a different variable here because I want to use the value as n. Now meaning the n is starting from 1 up to and then ending at 4. So I'm adding this one. This one is an n term for an even number. Now, so I'm adding all the even numbers from 1 to 4. So this one is so simple. Don't forget that this place is in terms of n. It can be in terms of any variable. Okay. Now let's move on. So wherever I see n, I'm going to put 1 there. Then I will replace it with what? Sum. This one means addition. So plus another number which is what? 2 plus 3, 4 up to the last number, that is 4. So I will have 2 times n starting from 1, then n start going to 2, and going to 3, and going to 4, and then that is all. Now let's see, 2 times 1 is 2, 2 is 4, 2 3 is 6, 2 4 is what? 8. So you can say this one they are all even number. That's why I said this one is the n term for even numbers. We have a way of generating this one. That one is to higher level, yes. Now what are you going to get? We're going to get 10. Everything will give us what? 20. So adding the even numbers from 1 to the 4 will give us what? Give us 20. Now let me add another one. Sometimes the question can be in a different form or any other way, but still supposed to be able to do it. Now let's see. Now we are adding r is equal to 1 to r is equal to 4 of r into bracket 2r minus 1. Now look at what we are doing. The thing can be in so many ways. Now, so this one means that I have to start from r is equal to 1 to r is equal to 4. You get it? Yes. Now follow me closely. So let's substitute. So the r here is 1. Multiplying this one 2r, this one is r. Multiplying 2r, r is 1 minus 1. So this is our first number. Now the second number is when r is 2. So 2 multiplying 2 r is 2 minus 1. The next number is supposed to be r is equal to 3. So let's put r is equal to 3 here. So we have 3. This r is 2 3 minus 1. The next number is r is equal to 4. So I have r is 4 2 4 minus 1. Now you just have to relax and stop the question. Simple. Now let's move on. Now I'll have 1, this one multiply this one give us 1 plus 2. 2 times 2 is 4, 4 minus 1 is 3. I have 3, this one is 6, this minus 1 is 5. I have 4, 8 minus 1 is 7. Now so when I move and I'm going to get 1 plus 2 3 is 6. 3 5 is 15. And then 4 times 7 will give us 28. Now then we add the whole of this one. Now so this one plus this one will give us what? This one plus this one will give us 30, 43. Then 43 plus 1, 44 plus 6, 50. So the whole of everything will give us what? It will give us 50. So that is how the thing is. It is very simple. It is not anything difficult. Now let's talk about another one. Let me give you another question. So sometimes it can also be written like this. We are adding from r is equal to 1 of x plus 1 squared. X plus 1 squared. Now how am I going to solve it? No. R plus 1 all squared. Now this one, r is starting from 1 to 3. You can also write just 3 here. Or sometimes you can just see it like this. It's still the same thing. Yes. Now let's move on. So we're going to get, let's start by putting the value of r inside this particular expression. So we have r is 1 plus 1 all squared. The second one is r is 2. Put the 2 here. So we have bracket 2 plus 1 all squared. The next one is r is 3. Now put the 3 there. So we have 3 plus 1 all squared. Now the rest will be simple. 1 plus 1 is 2. We have 2 squared. 3 plus 1 is 3. So we have 3 squared. We have 4 squared. Right? Yes. Now, what is 2 squared? 2 squared is 4. 3 squared is 9. And then 4 squared is 16. Then this one gives us 20. So everything will end up getting 29. 29. It is as simple as that. It is very, very simple. It is very, very simple. Now go ahead and try this question. I want you to go ahead and try this question. Now, question 1, you are summing x squared from x is equal to 1 to x is equal to 6. And then 2, you are going to sum r is equal to 1 to r is equal to what? 4 of 1 over r plus 1. So you're going to try this question and I'll meet you in the next video. Bye bye.